Hello friends, I am Dr. R.B. Solanki Vasantrao Naik, Art Science and Commerce College Shahada, Department of Chemistry. So for T.Y.B.Sc Semester 5 for the subject Principles of Physical Chemistry. In last lecture we have discussed about electrochemical cell, its classification and equation we have derived for the EMF of the chemical cell with transference. So now this is unit second, chemical kinetics. So this chapters, that is unit second, is for 15 marks for our NMU syllabus. Now introduction. So chemical thermodynamics deals with the spontaneity of reaction or process. So spontaneous process which carried out on its own accord, these are called as spontaneous or natural processes. So for spontaneous reaction, delta G must be negative. Delta G, that is the free energy change for any process or reaction, it must be negative. When it is negative, then the reaction is spontaneous. So chemical thermodynamics also provides the information about the extent to which reaction occurs, provided the reaction is spontaneous. There are about two more aspects about a chemical reaction. So there are two aspects for the chemical reaction which is takes place. First is the time in which reaction goes for completion. So time factor is important for here. And second is to know the mechanism or path by which reaction proceeds. Both these aspects are deals with the branch of physical chemistry that is called as chemical kinetics. So study of reaction path or mechanism with time, it is the chemical kinetics. Now we have to know the concept of reaction rates. So as the reaction proceeds, the concentration of reactant decreases while that of product increases. So here A gives B. This is the reaction. Here A is reactant, B is product. So here concentration of reactant decreases and concentration of product increases. At start, A, that is reactant, is 100%, B is 0. But at the end of the reaction, A is 0, B is 100%. So A is reactant, B is product. As the reaction proceeds, the concentration of A decreases and that of product B increases. Thus, the reaction or rate of reaction is defined as the decrease in concentration of the reactant in unit time or increase in the concentration of the product in unit time, represented as so minus d dt of Ca or minus plus dt of Cb. So Ca is concentration of reactant, Cb is concentration of product. So Ca and Cb are the concentration of reactant and product respectively, and the negative sign indicates that there is decrease in concentration of the reactant, and the positive sign indicates that there is formation of product. There is 100% formation of product, so there is formation, so it is positive. The positive sign indicates the concentration of B, that is the Cb increases. Concentration of A and B are expressed in moles per liter. So in the rate equation, that is d dt of Ca or d dt of Cb, Ca and Cb representing the concentration of reactant and concentration of product respectively. Now after studying the rate, here we have to discuss about factors affecting the reaction rates. So the reaction rates which depends on following factors. So the factors are, first is temperature. So the increase in temperature increases rate of reaction. As the temperature increases, rate of reaction increases. The rate of some reactions are doubled when the temperature is increased by 10 degree centigrade. Due to this dependence, rate of different reactions are to be compared at the same temperature. So the reaction will be considered or carried out in thermostat to control the temperature. Hence, kinetic studies of temperature reactions are kept constant by means of thermostat. Second factor is concentration. So it is observed that the rate of the reactions directly proportional to the concentration of the reactants, because the reaction rate depends on the concentration of the reactant. So during the reaction, concentration of reactant decreases and concentration of product increases. So that is minus ddt of Ca is proportional to Ca, or plus ddt of Cb is proportional to Ca. So this indicates, here negative sign indicates decrease in the concentration of the reactant, or the reaction rate decreases with the time as the concentration changes. Now third factor is presence of catalyst. So the presence of third substance other than reactant may affect the rate of reaction. So the catalyst is taking part in the reaction, but it remains as it is at the end of the reaction. So it is catalyst. So a small amount of catalyst is used for, or it is sufficient to alter the rate of reaction markedly. Further, it remains unchanged at the end of the reaction. So in this way, the presence of catalyst affect the rate of reactions. Friends, the fourth factor which affect the reaction rate is the particle size of the reactants. This is the very important factor. This factor is as important because the reactant is when solid state, smaller are the particle size, faster is the reaction rate. For example, when zinc dust is reacted with dilute hydrochloric acid, very faster than the granules of zinc. Besides these factors, the rate of some reactions depends on whether they are carried out in dark or light. So already we have discussed about the four factors on which reaction rate depends, but another important factor which is the light. So when reaction is carried out in presence of light, the rate of reaction is very rapid. Such reactions are called as photochemical reactions. So such reactions which are carried out in presence of the light are called as photochemical reactions. So in this way we have discussed the all four factors on which the rate of reaction depends.